So our second method here talks about where you can use your Pascal's triangle. Let's just draw a Pascal triangle to the point where we have the power to be 2. So we have 1, 1, 1, 1, 2, 1, right? That means this is what we are considering because our power is what? Is 2, right? Alright, so the first coefficient here is what? Is 1. So you don't need to do 2 combination 0 anymore here. It's just the coefficient. You know, our combination there was being done to determine the coefficient for each of the term as we move on, right? So yeah, our first coefficient is 1. This is it. Then multiplied by our first term, x. Remember I said for your first term, it is what? The first term is reducing by what? By your r. That's 2 minus 0. First term. Second term is increasing by your r plus y raised to the power of 0. Right? Right? Alright. So then moving on, plus the next coefficient here gives 2 multiplied by x raised to the power of what? 2 minus 1. Your first term is reducing by 1, reducing by your r, right? Exactly. So we have this. Then multiplied by your second term is increasing by 1, increasing by your r. You can say it's increasing by 1 or it's increasing by r. It's a logical thing. Alright, so plus y raised to the power of 1, right? Then add, what's our next coefficient here? 1 multiplied by x. Our first term is reducing by 2, so this gives 2. Sorry, our first term is reducing by 1, so this 2 minus 1. 2 minus 1 is 1, so 1 minus 1 will still give us 1, right? But let's just write it because of concept. That's 2 minus 2. Did you get that? Yes. Then multiply by our second term, which is plus y, is increasing by 1. This one becomes 2, right? What did I tell you? Once you get to that point where your last digit there is giving the sum of your initial power, you stop there. Alright, where you can no longer go further. Look at it now. There's no any other coefficient to move forward, right? That tells you that you are stopping automatically at this point, right? So we have 3 terms here. This is first term, the next term, right? First, second, and third term. Do you get it? So what does that tell you now? It tells you that your power determines the number of terms you have for your what? For your binomial expansion. It tells you that what? The power you have determines the number of terms you have for your binomial expansion. Now here my power is 2. To get the number of terms I have for my number of terms for binomial expansion, to be what? My power, which is 2, add 1. That's the number of power plus 1, right? So that means we are going to have 3 terms here for what? For this binomial expansion. Why? Because our power is 2. To get the number of terms you have, you add 1 to it. That gives 3. That's why we have 3 terms here. Do you get it? Please take note of that also. Please, it's very important. Alright. So moving on, expressing this is 1 times x raised to the power square. 2 minus 0 gives 2. Multiplied by plus y raised to the power gives 1. Plus 2 times x raised to the power 2 minus 1 gives 1. X raised to the power of 1 is still x, right? Multiplied by. Please, if you have issues with indices, please, you need to go back to get these things clarified. It's very important, please, because these are basic concepts that we should know. Alright, so plus y raised to the power of 1 still gives what? Still gives plus y. Okay, then plus 1 times x raised to the power of 2 minus 2 gives 0. So x raised to the power of 0 is what? Is 1, right? Plus, this is plus y raised to the power squared, right? So 1 times x squared times 1 gives what? Gives x squared. This times this gives plus 2xy. 1 times 1 gives 1 times plus y squared gives plus y squared. And this settles for our answer. And this is it. As simple as this. You get it? Alright.